Hey everyone, and welcome. Today we're going on an incredible journey, the journey of light itself. We're going to follow it from the very moment it's created, all the way to the instant it strikes our eyes, which literally makes our world visible to us. So, let me ask you a question. What could a giant star like the sun and a tiny little firefly possibly have in common? It sounds a bit random, right? Well, the answer gets right to the heart of what we're talking about today. They are both sources of light. And by the end of this, you'll understand exactly what that means and how it shapes everything we see. All right, so every journey has a starting point. And for light, that story begins at its source. So let's dive in and find out where light actually comes from. Okay, so as you can see, light sources basically come in two flavors. You've got your natural sources over on the left, the big one, the sun, which is the ultimate powerhouse for us. But you also have things like lightning, fire, and even living light from creatures like fireflies, which is just amazing. Then on the right, you have all the artificial sources, everything we humans have come up with to light up the darkness. We're talking about everything from a simple light bulb to the very screen you're looking at right now. So once light pops into existence, it starts this epic voyage. Now we're going to look at how it actually travels, sometimes across distances that are just impossible to imagine, all to get to us. Now this is where light gets really special. Think about sound. Sound needs something to travel through, right? It needs particles in the air to vibrate. But light? Nope. Light doesn't need a medium. It's an electromagnetic wave, which means it can zip right through the total emptiness of space. That's how the sun's light gets to us from 93 million miles away. It's just incredible. And just how fast is it traveling? Get ready for this. It's moving at a mind-boggling 300,000 kilometers per second. Let that sink in for a moment. That is so fast, it could go around the entire planet more than 7 times in the time it takes you to blink. It's the absolute speed limit of our universe. Nothing, and I mean nothing, can go faster. So light likes to travel in a straight line, but its journey isn't always that simple. The world is full of stuff, right? And when light hits an object, one of 3 things usually happens. If the material is transparent, like clear glass, the light just passes right through. If it's translucent, like frosted glass, some of the light gets through, but it's all scattered and messy. Or if the object is opaque, think of a block of wood, the light gets stopped in its tracks. It's either absorbed or bounced right off.
And that brings us to the grand arrival, what I think is the most interactive part of light's whole journey. What happens when it finally hits all the objects around us? This is where we get into the cool rules of bouncing and bending.
First up, we've got reflection. The easiest way to picture this is to think of a bouncy ball hitting a wall. Bounces right off, right? Light does the exact same thing. When it hits a surface, it bounces. This simple, fundamental property is the reason we can see pretty much everything around us that doesn't make its own light. But, not all bounces are the same. When light hits a super smooth surface, like a mirror, you get what we call regular reflection. All the light rays bounce off at the same angle, and that's what creates a nice, clear image. But what about a rough surface, like a piece of paper? Even though it looks smooth to us, on a microscopic level it's bumpy. So when light hits it, the rays scatter in every direction. That's called diffuse reflection, and it's exactly why you can't see your reflection in a wall. Okay, so this process of seeing yourself in a mirror tells us something really important. A mirror doesn't make light, it just redirects it. So think about it. Step 1, light from a lamp or the sun hits you. Step 2, that light bounces off of you and shoots over to the mirror. And then step 3, the mirror reflects that light perfectly right into your eyes. And boom, you see yourself. It's a perfect example of reflection doing its thing. All right, next rule of the road for light is something called refraction. And really all this means is the bending of light. You've totally seen this before. When you put a straw in a glass of water and it looks like it's broken or bent right at the surface? That's not a magic trick. That is refraction in action. So why does light bend in the first place? Well, it all comes down to a change in speed. Light travels super fast through something less dense, like air. But when it hits something denser, like water or glass, it slows down. I love this analogy. Imagine you're driving a car and one of your front wheels hits a patch of mud. That wheel slows down first, right? And that causes the whole car to turn a little bit. That's exactly what's happening to the light. The change in speed forces it to bend. And last but not least, we have one of light's most beautiful tricks, dispersion. This is the moment where white light, like the light from the sun, shows its true colors, literally. See, white light isn't really white. It's actually a mix of all the colors of the rainbow, all traveling together as one team.
And this is exactly how we get one of the most amazing shows in nature. When sunlight shines through millions of tiny raindrops in the air, each one of those little droplets acts like a tiny prism. It bends and separates the white light, fanning it out into all its different colors. And when you put millions of those together, you get a magnificent rainbow painted across the sky.
Okay, so we've followed light from its source, we've seen it travel at these insane speeds, we've watched it bounce and bend all over the place. But why does any of this really matter? Let's talk about the final and most crucial impact this journey has on our entire world.
To put it as simply as possible, without light, there's no life as we know it. It's the energy source for photosynthesis in plants, which is the foundation of pretty much every food chain on this planet. And for us humans, sunlight helps our bodies make essential vitamin D, and it's also what keeps our internal clocks, our natural sleep-wake cycles, running smoothly. It keeps us healthy and in sync with the world.
But here's the thing. Because light is so powerful, we also have to be smart about how we deal with it, especially now that we live in a world just filled with screens. So let's wrap up with a quick guide on how to use light safely.
Here are 3 simple but really important rules to protect your eyes. Number 1, and this is the big one, avoid looking at the sun directly. Seriously, never do it, and wear sunglasses on bright days. Number 2, try to keep your distance from screens when you can. And number 3, if you're on a computer all day, try the 20-20-20 rule. It's super easy. Every 20 minutes, just look away for 20 seconds at something that's about 20 feet away. It's a fantastic way to give your eyes a break and avoid that digital eye strain.
So there you have it. From the tiny glow of a firefly to the giant, beautiful arc of a rainbow, the incredible journey of light is what makes our world visible. It literally illuminates everything we know. But it also makes you think, doesn't it? With everything that light shows us, what mysteries are still out there, hiding in the shadows, just waiting for us to find a way to see them. Thanks so much for joining me today.